Okay. What's up, everybody? It's your boy, Mr. Torres, and here I'm going to share my screen. Alrighty. So, today we're going to be going over atomic structure. Super important. This is like very foundational stuff, whereas we're starting to get into a little bit more detail on how we're learning more about chemistry. Now we're learning after learning about the history of the atom, and now we're going into the structure. Okay. So after today, today we're gonna touch base on what an atomic number is, what's the mass number, and what's an isotope. After today, you're gonna be able to use your periodic table, and you're gonna be able to identify and find atomic mass, atomic number, symbols of the elements of the periodic table, and then you're gonna be able to calculate that number of neutrons in a particular atom. Then you're going to understand and differentiate the properties of isotopes of a particular element. So let's get started, right? Let's start off with atomic number. You may ask, what's an atomic number? Well, when I have words I don't understand, I tend to break them down, right? So if I take away the IC in atomic, I have atom. So I look at it, it's like, okay, atom number, atomic number. So it's the number associated to the atom or to the element, right? So the number of protons in an element is the atomic number. It's always a whole number. It's never going to be like 1.1, 1.3, or 7.6. It's always going to be a whole number. So example, oxygen has an atomic number of 8, and that means that there is 8 protons in the oxygen's nucleus. Okay. Atomic numbers also refer to the charge of an atom. So for neutral atoms, no charge, the number of protons is going to equal the number of electrons. So some atoms can be positively charged, some atoms can be negatively charged, some atoms may not have a charge at all. And when understanding what their charge is, it may affect the ratio of how many uh, protons there are and how many electrons there are. Okay, so the number of protons will never change for an element. The atomic number is literally going to be the social security number of that element, as said here. It identifies them. So every element's going to have that specific number, and it's always going to refer back to it. Just like you, your social security number makes who you are. Okay, next. Let's learn about atomic mass. So here we have 4 elements on the right-hand side right here. We have krypton, beryllium, manganese, and sulfur. Um, and then we have a bunch of numbers here. You're like, what is this? What does this mean? So atomic number, remember what we just learned is the number of protons in an element. It's also going to give it its identity. So if I were to cover the Kr up here and I say, hey, what element is atomic number 36? If you look at the periodic table, you should be able to find out that it's krypton. So by the way, if you haven't yet, type in Google periodic table of elements, and you should be able to find a periodic table there. Click it, and it'll give you all this information. But what's this number you say right below it? Atomic mass, right? It says 83.80. It's a wonky number. It's pretty big. You know, it's bigger than 36. So it's like, what makes it different? Find out. So the atomic number, or sorry, the atomic mass can be read right off the periodic table. You'll find that information just like the atomic number. This number will have a decimal because a lot of these particles or components of the atom are going to be like have a very specific, accurate weight, right? And it's a weighted average of all the elements isotopes. So I haven't taught, we mentioned the word isotopes. I'm not going to get into it right away because it'll just confuse you. So let's just stick to the basics here. Let's talk about more about atomic mass. The difference here, we have atomic number and atomic mass. These are two correlative numbers, meaning they have something to do with each other, but they're not exactly each other, you know? So On the top number, we need to be able to find the difference between atomic number and atomic mass. If you look at this one, we have oxygen. The number above oxygen is the atomic number. Okay, so think about it. Whenever you need to find the atomic number, you look up and you find 8. 8 is going to be the number of protons in oxygen. Now, when you weigh yourself on a scale, you find out how much you weigh or how much mass, how massive you are, right? So atomic mass is always going to be found below the element. So either the letter or the name. So you're going to have 15.99, right? You look down and you look at your weight. So that's how much the actual entire atom weighs. So one atom of, or one molecule of oxygen is going to weigh 15.9999, or you can round it up to 16. Excuse me, not enough coffee. Okay, so we're going to look here, the mass number. Mass number is the number of protons and neutrons combined. So if you know what the atomic number is and you know what the mass number is, if you find the difference of those two, you're going to find out what how many number of neutrons are in there. So again, that number is always going to be a whole number, the mass number. Oopsie, why did I do that? Okay, so finding the number of neutrons. I gave you a little brief little overview of what that was. Neutrons, you're going to find that by taking the difference between the mass number and the atomic number, or you can just take the mass number minus the atomic number and you'll get that. Example, right? So we're using oxygen again. So I rounded up its mass number, or its atomic mass, and that was the number 16. We know that the atomic number of oxygen is 8. So if we take 16 minus 8, that should give us the number of neutrons. Mentioned it before. Hey, that's my little cat. He's saying, "What's up, guys?" Right? So isotopes. Isotopes are atoms with the same number of protons but different number of neutrons. They're chemically alike and they have different mass numbers. For reasons that we just identify and we know, but how they happened, I have no idea. So we look at them as like this. So the element, the specific element, if it's like hydrogen or something, and then the mass number. The mass number representing the different variation of that element. So what the hell are you talking about, Mr. Torres? So let's look at this, right? Let's look at an example. We have hydrogen 1, hydrogen 2, and hydrogen 3. Hydrogen has 3 isotopes, 3 variations in which it has the same number of protons, but it all has different numbers of neutrons. So let's look at it. Let's look at these diagrams. So we have this one, we have this one, and have this one. If you take a moment to look at it, you have different things happening in each one of them. You have uh, a red orb here, a brighter red orb, like a maroon orb, same thing as that one, but with a blue, a maroon, and 2 blue. So this was these little red orbs in the center are going to represent the number of protons. So hydrogen has an atomic number of 1, and it's going to be represented by the number of protons. So we have 1 here, 1 here, and 1 here. If it had a different number of protons, it wouldn't be hydrogen. So hydrogen is typically neutral, so it is matched with a equivalent of 1 electron, as shown here. So electrons are usually like cool cats. They like to chill out and be out on their own and move a lot. So you can see that, 1 electron in each. And here in hydrogen 1, we don't have any neutrons. There's no blue orbs here. In hydrogen 2, you have 1 neutron. And in hydrogen 3, you have 2 neutrons. So looking at it, an isotope is an atom that has a different number of neutrons, even though identically and chemically, it is the same. Like hydrogen is still hydrogen because it still has one proton and one electron, but it has three different isotopes because it has a different number of neutrons. 0 in the first, 1 in the second, 2 in the third. So in summary, remember, atomic number equals protons, and protons equals electrons if it's a neutral atom. The mass number is going to equal protons plus neutrons, and neutrons are going to equal the mass number minus the atomic number. So I would take this on your exit ticket that I posted. There is a chart you need to fill out, and I'm going to pull it up in a second. You need your periodic table of elements, and you need these three little equations, or these three little references. And this is going to help you be able to fill out this table correctly. You think you got it? All right, let's do this. So we have this exit ticket right here. You guys were probably like, what the heck is this, mister? What is this? You didn't talk about this. Well, I'm talking about it now. So here we have this row, or this column right here is going to be the element symbols. This one, atomic number, mass number, number of protons, number of neutrons, number of electrons. Remember, if you know any two of these pieces of information, you will be able to solve this. It's like a puzzle. So let's do the first one, right? Element symbol for S. S, and I'm tab out here, we have sulfur. Sulfur is right here. The atomic number is located above, and it has 16, and below is atomic mass, mass number being 32. And we know that the atomic number is equivalent to the number of protons. So if you go here, we know now that the atomic number is 16. The number of protons has to be, 16. But we know that the mass number here was 32.06, or 32. So we can say that here. And remember, atomic number is equivalent to the number of protons, so that's going to be 16. Sulfur does not have a charge, and they already gave us the number of neutrons. But if you wanted to double check, remember the number of neutrons is the mass number minus the number of protons. So 32 minus 16 would be 16. And in a neutral atom, the atomic number equals the number of protons, which is going to equal the number of electrons. So we should have 16 here. I'm going to let you guys do the rest of these. Just remember, atomic number is going to give you is the identity of the element. So real quick for the second one, atomic number. If the atomic number is 7, that means we have to go in the periodic table here and look for 7, which is nitrogen. Nitrogen has atomic number of 7, and it has 14.007 atomic mass, and or the mass number. So it's going to be 14. So this element has to be nitrogen. The number of protons is equivalent to the number of the atomic number, so that has to be 7. The number of neutrons is equivalent to the mass number minus the atomic number, which is 14 minus 7, so that should be 7. And if this is a neutral atom, the number of protons is going to equal the number of electrons, so it should be 7. If you need any help, please feel free to email me, message me, and we'll Zoom and we'll walk you through this. So happy New Year's, guys. Look forward to seeing you next week. I'm out.